So this video is for integrated 2MA. This is the 2-12 to 2-16, which was the classwork / putting in our composition book notes, dealing with flowchart proofs and 2-column proofs. So starting with 2-12, if I'm looking at this picture here, I notice that I have this side with a length of 6. Thicker. Okay, this side with a length of 6, AB. I also have that same length over here. I see that BC is a length of 4.5. Oops. And ED is a length of 4.5. And AC. Okay, we've got all those that are the same length. So what they want us to do is they want us to determine if these triangles are congruent, and if so, why, and then do a flowchart proof. So these triangles are going to be congruent by side, side, side congruence. But we have to do a proof of this, and we're going to do, again, something called a flowchart proof. So in this situation, what I'm going to do is I'm going to start with my pink lines, sides here, AB. Okay, and I'm going to say AB, and when I don't put a line over it, it's not talking about it as a line segment, it's talking about it as a length. So AB is 6. In the other triangle, I'm going to keep the order. So I'm going to say FD also has a measure of 6. I'm going to put a circle around it. This is called a statement. Now, inside is the statement, outside is a reason, and the reason is given. That's our reason. Now, what that's going to lead to us being able to say that line segment AB is congruent to line segment FD, since they are the same value, since they are equal. And the reason for this is definition of congruence. Now I'm going to do the same thing with the next side, BC. So the length of BC is 4.5. Now, again, I want to keep that order in the other triangle. So in the other triangle, BC would correspond to DE. So DE is 4.5. Reason given. This is leading to the statement that BC line segment is congruent to line segment DE. Again, the reason, definition of congruence. Okay, now I'm going to talk about my third side. Okay, so AC is equal to the length of AC is 7.5. AC is going to correspond to FE. So FE is also equal to 7.5. And again, the reason is given. Now, knowing that leads to me being able to say that line segment AC is congruent to line segment FE. And again, the reason, definition of congruence. So now, since I have these three sides being congruent, I can say that these triangles, that these angles being congruent leads to the fact, okay, so let me draw arrows showing the flow of the proof, leads to the fact that these two triangles, I'm going to call the first one ABC, is congruent to triangle. Now, A corresponds with F, B corresponds with D, and C corresponds with E. So I can now say triangle ABC is congruent to triangle FDE, reason, side, 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 congruence. And that's the end of my proof. So let's take a look at the next one. This one, 2-13. Okay, so let me just take a look at the picture here. So looking at the picture, I have this side QP that is 6. I have this side ST that is 6. I have this angle here, that's 120 at P, and this angle here, that's 120 at T. Now, they did not mark it, but I know that this angle here is congruent to this angle here because of vertical angles. So now looking at my picture, I have this side with the 6 congruent to this side, and I have my blue and my green angle. Now, when you have two sides and an angle, you have to pay attention to where two angles with a side. You have to pay attention where the side is. The side is not in between these two angles. That would be angle, side, angle. So we have angle, angle, side. That's what we have. Okay, just to focus ourselves. Okay, so let's get started, just like we did in the last one. I'm going to get started with the line segments. So I'm going to say QP. QP, the length of QP is 6. And Q, that corresponds with S. So I'm going to say ST, the length of ST is 6. And the reason is given. Now that leads to me being able to say that line segment QP is congruent to line segment ST. Reason, definition of congruence. Okay, now I'm going to talk about the angles here. So I'm going to say measure of angle P is equal to 120 degrees. Measure of angle T is equal to 120 degrees. So since these both have the same measure because of given, that's going to lead to me being able to say that angle P is congruent to angle T. Reason, definition of congruence. Now that green angle right here and here, I cannot call that angle R. Okay, so there and there. I cannot call that angle R. Let me just get rid of the arrows. There's too much going on here. So I'm just going to kind of highlight it and then I'm going to undo it. So I can call this one PRQ. You can kind of see as I was doing it, PRQ, it formed that angle there. I could also call that same angle QRP. Now, what has to happen is the R, which is where the vertex is of that angle, has to be in the middle. So I am going to say, and I don't have to say, so the other ones, because I wasn't given the marks or that I could say it was congruent, I was given measures. I had to say that what the measures were and then say that they're equal. And that led to congruence. In this situation, I'm going to say that angle P, I'm going to say PRQ is congruent to angle. And in the other triangle, P corresponds with T, R corresponds with R, and so that's going to leave S here. And the reason we are saying this is because vertical angles lead to congruence, okay? They're congruent. So now looking at that picture, I have my angle side. I have all of those in my proof here. So now I can say that this and this and this are leading to the statement that triangle, and I'm going to do the first one. I'm going to call it QPR. QPR is congruent to triangle. And since I said Q first, Q corresponds with S, P corresponds with T, and then R. And the reason for this was angle, side congruence. Okay, so let's go to number 14. So on 14, it says, suppose you're working on a problem involving two triangles, triangle UVW and triangle XYZ. And you know that triangle UVW is congruent to triangle XYZ. What can you conclude about the sides and the angles of the two triangles? Write down every congruent statement, including sides or angles that must be true. So if they gave me this, I'm going to write it triangle UVW, okay? And I'm going to write the other triangle underneath so I can match things up easily. So it was X, Y, Z. So there's going to be 6 things that I can say. So the very first thing I'm going to say is that angle U is going to be congruent to angle X. Angle V is going to be congruent to angle Y. Angle W is going to be congruent to angle Z. Okay, those were the angles. And you'll notice that I lined them up. I also color coded them, but you can see them right underneath each other. So now I'm going to do segments. Okay, so now I'm going to say line segment. And let's say I do this. I'm going to do UV. So if I'm doing UV, I'm going to do XY because they're in the same spot. Okay. So I am going to say line segment UV is congruent to line segment XY. Okay, let's say I do this pair here, VW and YZ. Okay, so I can also say that VW is congruent to line segment, okay, and VW is going to be corresponding with YZ. And I'm going to have one more. So let's say I do these ones here on the outside. Okay, those ones there on the outside. So I am going to say that, let me just get this written here. Okay, I'm going to say that UW is congruent to line segment XZ. And those, let me write my Z, and those are the 6 pieces, 3 angles, 3 sides. Okay, so now let's take a look at number 15. So on number 15, let me just get rid of this. So on number 15, they have a proof partially done for us, but we need to come up with the reasons. So they gave us this quadrilateral with some markings in it. And what they want us to prove, I'm going to highlight what they want us to prove. I'm not saying that these are congruent. This is what we're trying to prove. We want to prove that this is congruent to this. That's what we're trying to prove. Okay, not something we know. That's what we're trying to prove. Now, looking at this, some of the things that we know that this line here is parallel to this line here. Okay, and that's what they stated right here. They gave us that. They gave us that. So the reason for that is going to be given. Now, they have an arrow coming from that down to the statement that angle ADB is congruent to angle CBD. Okay, so angle ADB is right there. And that's congruent to CBD, which is right there. Now, the reason that is, if I zoom in, we have parallel lines cut by this transversal that I just drew in there. Okay, so we had parallel lines cut by that transversal is cutting my parallel lines. Okay. And so you see that those two angles are labeled there. Okay. Okay. So the reason we can say this is because parallel lines lead to alternate interior angles congruent. That's going to be my reason. Okay, so now they gave us in another circle. Okay, let me just kind of get rid of some of the stuff that I drew in here. Okay. Okay. So they gave us that angle A is congruent to angle C. Okay, so angle A up here is congruent to angle C. And the reason is given. They gave us that. Now, there's something that they didn't give us, but we know it's going to be true. This line segment here, okay, is going to be congruent to itself. And that they gave us right here. Okay. That's what that is dealing with. Okay. So the reason for that is reflexive property. Reflexive property of congruence. That's why. Okay. So again, this here was this pink and this pink. Okay. And this here was that orange line. Okay. Just to kind of help us see things. Okay. So knowing that and looking at my picture, we have enough information to say that these triangles are congruent. I'm just going to zoom in. So I have an angle and a side. Okay. Two angles and a side, and it's not the side in between. So it's going to be angle, side congruence. So now they're going to say, let me just kind of get that still in the picture. So we're going to say that this is angle, side congruence. Okay. But that's not helpful. So we prove that these triangles are congruent, but that's not what they asked us. They didn't ask us to prove that the triangles are congruent. They wanted us to prove that this purple line segment was congruent to this purple line segment. I didn't prove that. I don't have enough from the picture to prove that. But what I do know is that if the triangles are congruent, then their parts are congruent. So that's allowing me to say that since the triangles are congruent, it leads to line segment AB being congruent to line segment CD. And if you look here, you see A, B, C, D. It's in the same order. So the reason for this, we can say CP, CTC, or congruent triangles lead to congruent parts. So sometimes we can't prove the angles or the sides being congruent. We don't have enough information, but we can prove the triangles are congruent, which leads to the parts being congruent. Okay, so let's take a look at the next one. Number 16. Okay, so on 16, this one I'm going to do a 2-column proof. And a 2-column proof is basically the same as my flowchart proof, but instead of having the statements in the circles and the reasons outside, we're going to have 2 columns. So we're going to have a column for statements. And a column for reasons. Now, We're trying to prove in this that the triangles are congruent, and if not, then we have to say why not. We don't have to prove it, we just are going to say it. So in this situation, I'm just going to kind of color code some things. Okay, so we know that angle D and angle B are congruent. I notice that they share this side, so that's a side that they're going to have in common by the reflexive property. I notice that we have parallel lines. Okay, so we have these parallel lines cut by that orange transversal. Now, since I have that orange transversal there, in between the transversal and the green parallel line, the transversal and the green parallel line, we have alternate interior angles are congruent. So we just get rid of those. So what I'm going to say here is a couple things. I can say, number one, I'm just going to write that a little smaller, sorry. Number one, angle B is congruent to angle D. Reason given. I am going to say, number two, that line segment AC, okay, is congruent, and if I'm doing it in order, and the other triangle would be CA. And the reason for that is going to be reflexive. Property for congruence. Now, my third thing I'm going to say is that line segment AB is parallel with line segment, and I'm going to keep the order. So AB, I'm going to say CD. Reason given. Now, given that information that those are parallel, I know that angle BAC, okay, and here maybe I'll do it in purple since I drew it in purple so we can see it. Okay, just so we know what matches. Okay, so angle BAC is congruent to angle DCA. Reason? Parallel lines lead to alternate interior angles congruent. Okay, now I have enough information at this point to state that these triangles are congruent. Looking at this, I have angle, side. That's what I have. So I'm going to say triangle, and I'm going to call it, I'm going to go pink, purple, no color. So I'm going to say DCA. DCA is congruent to triangle BAC. Reason, angle, side congruence. And so that's the same as what a flowchart proof is, but it's called a two-column proof. Again, all of these statements would have been, let me get something so you can see my cursor. All of these statements would have been inside the circles. All of these reasons would be outside the circle. Now, flowchart proof, we do draw arrows leading to the next idea. Okay. Here we don't draw arrows, but you want to kind of have it in an order that makes sense as you're going through this. Okay, so let's take a look at number 16B. So on this one here, I noticed that I have this 50 degrees and 50 degrees. So I've got two angles. Now the problem is this measure here, FG, is not the same as this measure here. So this is not going to be congruent. because, and let me say this, we would have this angle here at H. When I say at H, these two angles, so FHG and JHI, would be congruent because of vertical. But that doesn't matter because the 5 and the 4 should be the same if it's going to be congruent. So not congruent because FG does not equal JI. They are not equal to each other. Okay. So let's take a look. So we're done. We're done with that one. So let's take a look at 16C. Okay, that's gonna be on the back of your worksheet. Okay, so 16C. So this one here, I notice that I do have a right angle. Okay, so we have a right angle. So maybe hypotenuse leg. Now I notice in the smaller triangle, okay, let me just draw that triangle out. Okay, I'm going to draw it in, let's say blue. Okay, so this one is going to be, let me just kind of color code this, sorry. This one is going to be my blue one. And let's say the other one, let's say it's going to be orange. Okay. So when I'm looking at my blue one, let me just draw a right triangle. Okay, so here's my right triangle. And again, this is S. This is S. This is U with the right angle here. This is T. We are going to have a 3 and a 2 here, okay? And then this is our hypotenuse. We don't know that. Okay, so right now this would not be hypotenuse leg at all because I don't have my hypotenuse. I could find it doing Pythagorean, but that's not going to be our situation here. Now, I notice that they both have a 3. See how they both have a 3? But the 3 is not going to be necessarily in the same position. So let me draw the other one out in orange. Okay. And so let's say, which way I want to do it. Okay. Let me just move it. Okay. So for this one, okay, I have U, T is the right angle, and this one and V. This is our 3, okay, which those correspond, and then this is the 6. Now, the problem is the smallest side in the blue one is a length of 2. The smallest side in the orange one is a length of 3. Those two sides should be the same if it's going to be congruent. So we're going to say not congruent, not congruent because the two smallest sides SU, line segment SU and UT are not equal. So that's not going to be congruent. Last one, D. Now for this one, I do see that we have a right triangle. I do notice that we have this side here, this hypotenuse. And so make it straighter. This hypotenuse and this hypotenuse are both 13. Okay, they're the same. They both have a right angle. Now they both have a leg, but they don't have the same leg. So I can do a couple different things. I am going to do Pythagorean in, and I'm going to just color this. So let's say that I have this one be my blue triangle, just so I can reference it. And let's say that the other one I have be my pink triangle. Okay, so I'm going to deal with my blue triangle, okay? I'm going to deal with my blue triangle, and I'm going to do Pythagorean. So I know that 5 squared, I'm just going to write a little smaller. Shrink that down to a 2. Okay, so I know that 5 squared plus, let's say, I'll call this b, plus b squared is equal to 13 squared by Pythagorean. So 25 plus b squared is equal to 169. I'm going to subtract the 25 from both sides, which is going to give me a 144. I am going to take the square root, and really when I take the square root, I get two answers, positive and negative, but I'm not going to have a negative side of a triangle, so I'm just going to take the positive one, which is a 12. Okay, so now I know that that side is going to be a 12, okay, by Pythagorean theorem, okay? So now I have that this side here, this 12, and this 12 are the same. So I have hypotenuse leg. Otherwise, it's side-side angle, which does not work. But for a right triangle, side-side angle is hypotenuse leg. So let's say I do a 2-column proof for this one. Okay, so I'm going to do statements and reasons. Let's change this color. Put that black. Okay, so statements and reasons. First thing I'm going to say, triangle, let's say I call it MKL. And triangle Q, let's see what I do, MK, QRP, QRP, R, let me give me a number 1 here, R right triangles. Number 1, given. Okay, number 2. The length of MK is equal to 13. The length of Q, so I said what, MK, QR, sorry, QR. The length of QR is equal to 13, given. And that means that MK, line segment, is congruent to QR, reason, definition of congruence. Now, we know that sorry, move that back. We know that PR is equal to 12, given. We know that, so I did PR, so I'll do LK is equal to 12. Reason, Pythagorean theorem. That was not given. I had to do work for that. That was Pythagorean theorem. So now that we know that LK is equal to 12, also because of Pythagorean, and let me write theorem here. Then what we can say is that line segment PR is congruent to line segment LK, reason, definition of congruence. So now from my picture, I'm going to stop. I'm not going to find the other side in the pink triangle. I could do that and do side, side, side. I have enough information now. So at this point, I can now say that these triangles are congruent. So I'm going to say triangle MKL, MKL is congruent to triangle. M corresponds with Q. And I'm going to move this. I always write too close. Okay, so let me just select that and scooch it out a little bit. Okay, so M is corresponding to Q. K is corresponding with R, and then L was the right triangle, so P. And the reason, getting too excited here, the reason is hypotenuse leg congruence. And that's the end of these proofs.